Well, hi, everybody. Welcome to transitioning from ROBOTC to VEX Coding Studio, week 1. This is the first of 4 webinars that we have planned. My name is Jesse Flott, and I will be leading those webinars. Today, we are going to talk to you a little bit about the Carnegie Mellon Robotics Academy, who we are. We're going to spend some time talking about the new VEX V5 system. That'll be important to the programming so that we can understand where some of these changes are coming from. We're going to, of course, introduce VEX Coding Studio, take a look at downloading a program inside of there, and then also point you to some additional resources that VEX has prepared for you. In future classes, we'll be sure to get an even deeper dive into the programming. Today is going to be mostly about orienting you to this new world. So first, just a little bit about the Robotics Academy. Our mission statement is to use the motivational effects of robotics to excite students about CS STEM. We've been doing that for a little over 15 years, doing that by working on curriculum, partnering with competitions, partnering with robotics organizations, and then also training and certifying teachers. So a very big part of what we do is professional development for teachers and coaches. We've trained a few thousand across different robot platforms, and our focus is largely on the programming. So helping teachers to be able to bring the programming for the robots inside of the classroom, helping students achieve learning outcomes in computational thinking, but also making sure that teachers and coaches are supported for the pedagogy and also the troubleshooting to be able to bring these things successfully inside of the classroom and create fun and engaging situations. So training is a huge part of what we do. Okay, so during the class today, I have kind of a set of slides and demos that I want to go through. At the very end, I'll try to do my best to answer a whole bunch of the questions. So do feel free to put your questions inside of the comments, and I will do my best to answer those at the end here. All right, so first, the VEX Edr V5. So the reason that the new system is called V5 is because it is considered the 5th generation for the VEX robots. You can see its predecessors here. Several of these robot platforms, the VEX PIC, the VEX Cortex, were programmable inside of ROBOTC. So maybe a lot of you have used these previous generations of the microcontrollers. The new system does represent a total overhaul. It has a new brain, new remote, new motors, some new sensors, new radio. It's really a powerful and valuable upgrade. I'm really excited about many of the enhancements to the system. If you're not familiar with them yet, we will look at just a few pieces. Again, because understanding some of the enhancements does help understand why some of the things inside of the programming have changed. The first thing that I want to focus on, and that I could not be more excited about, is the V5 robot brain. So with the VEX Cortex, you are able to build really impressive robots. You can have robots that have 10 motors or more if you have splitters, that use 12 digital sensors, 8 analog sensors, the I2C ports. You can really build a comprehensive, powerful machine. What I would say about the Cortex, though, is that it's a little bit limited in the user interface category. You're able to download one program at a time. And as far as the status of the robot, you have those 3 blinking LEDs. Well, the V5 is just light years ahead. It's a wonderful addition, wonderful upgrade, because it includes this beautiful LCD screen, touch LCD screen. So you're able now to download 8 programs. You can have 8 unique programs on the robot brain. You can also get tons of on-brain feedback and information about your robot. So rather than just those 3 blinking LEDs, you can check the values of your motors, the values of your sensors. Lots and lots of good stuff comes with having a user interface on the robot brain itself. And of course, you can still build really great robots. There are 21 ports, 21 smart ports that you can connect smart devices to, motors, sensors, radio. And the new motors are also more powerful. So you can, in theory, build an even stronger, bigger, faster machine. But it also contains 8 3-wire ports, so you can connect those 3-wire sensors and the older generation motors still to these robots. The new remote control or wireless controller is also a welcome enhancement. Since the robot has so much more memory and has a user interface, the robot brain actually has what's called a built-in drive program. So in the ROBOTC generation, in the Cortex generation, if you were downloading programs, then that meant you were wiping out your default drive program. Well, instead, the drive program is configurable on the robot brain, and it persists. Even if you download those 8 programs that I mentioned before, it always sticks around. So that's a really welcome change. But on top of that, you can still access values from it inside of your programs. So that capability is still all there. And then what's really, really, really cool is it has this screen on it that actually gives you status updates and allows you to make changes on the brain itself. So if you are working with your robot autonomously, or rather writing autonomous programs for your code, or even different remote control routines, you can start those and stop those from the remote control. You don't have to reach into your robot and try to go through the menu system and things like that. You can do it from the convenience of the remote. It works over VEXNet, it works over Bluetooth, so that's really powerful, and again, another welcome enhancement to the system. And the last component that I want to talk about, although there are other new components, are the new smart motors. And like the brain, like the remote, these are really, really bring a welcome change to the system. Previously, with the 2-wire motors, the 269s and the 393s, they were good motors, but they did not contain built-in encoders or built-in rotation sensors. So if you wanted to be able to do things like a PID control, if you wanted to be able to do things like control the distance your robot moves based on rotations, you had to add an additional component. You had to add those integrated encoders or those quadrature encoders. With these new V5 smart motors, every single one already contains an encoder. So right out of the box, you get PID control. Right out of the box, you get the ability to control the distance that your robot moves. And so that will make getting started a whole lot easier. It will also make what you can do with your robot, give it that much higher of a ceiling. That'll be really great. The other really cool thing that's not apparent from this slide is you can also change the gearboxes in a way that is visible from the outside. So with the 393 motors, you can swap out the gears inside of there. You can change it from high torque to high speed to turbo speed, and that's great. You can engineer different solutions. The only problem was you close the motor back up and visually you have no idea. Well, these new motors, you can still open them up. What you take out is like an entire gear cartridge, and they're color-coded, either green, red, or blue. And that change is visible from the outside. So this is great because it still gives you the flexibility of having a differently geared motor, but you'll have fewer programming mistakes. I don't know if any of you out there have ever put a motor on a robot only to find out that it had non-default gearing or different gearing than what you expected. But this makes it so it's really easy to use, really easy to visually inspect. So we're super excited about these motors. All right, so VEX Coding Studio. VEX Coding Studio is a very powerful programming environment. And already today, it supports multiple programming languages. It supports ModKit blocks and text. It supports VEX C++ and C++ Professional. And already today, you can use it for PCs and for Macs. Okay, so ROBOTC was locked in a world of Windows only, but right away today, you can download VEX Coding Studio from the VEX website. I have the URL here, but also if you go to the VEX website and go to the programming software section, you can find it that way. Okay, so you can download it today for PC or for Mac. All right, so a few of the things that I want to show you today are a few of the kind of getting started things that you'll need to do with your robot and with VEX Coding Studio. I'm going to show the slides first, and then I'll actually open up VEX Coding Studio and demo some of the steps inside of there. The first thing I want to draw your attention to is updating firmware. If you worked with the VEX Cortex and ROBOTC, you're probably familiar with this. One of the first things that you want to do when you get started is to make sure that your robot hardware is all the way up to date. So with the VEX Cortex system, you had your robot brain, you had the VEXNet joysticks, and you had the VEXNet keys. All of those had firmware that you needed to update. Inside of the V5 system, similar, but any device that's a smart device will have firmware. So the robot brain, the wireless controller, your motors, some of the sensors, the radio, all of those have firmware that you'll want to make sure is up to date. Well, the enhancement that's been made inside of VEX Coding Studio and inside of the new V5 system is, even though you have these multiple devices to keep up to date, to update the firmware, they've really done this intelligently, where inside of VEX Coding Studio, you update the robot brain, but when you do that process, it also transfers all of the latest updates for motors, for sensors, for the remote, for the radio to the robot brain. So instead of having multiple processes that you have to go through, multiple things that you have to plug in and unplug and try to keep all of those steps straight, what happens is you follow a sequence of steps to update the robot brain. After the brain itself is updated, it's smart enough to go out and check all the things that are connected to it. It checks, are my motors up to date? And if they're not, then, excuse me, on the robot's brain itself, it says, would you like to update the motors? Does the same thing for the radio, for the battery, and for the remote. So the robot brain maintains the latest version of the firmware and will update all of those devices. That's really nice because let's say, okay, you're building a competition robot maybe, and you've had some motors that have been sitting on the shelf. Well, whenever you hook them up to your robot, even if they're out of date, your robot will detect that and go ahead and update them. Okay, so they've really improved that system for this generation. Okay, some of the other differences are around configuring motors. Inside of ROBOTC, you probably got familiar, comfortable with the ROBOTC motors and sensor setup. Inside of VEX Coding Studio, you will still have the ability to add and configure motors, but it is a very visual interface, one that I think makes it more intuitive for students. So you're still able to give your motors names. You're still able to specify the port that they're on. You can also specify the different gearbox, but all of it is visual and colorful and intuitive. Same goes for the sensors. So previously in ROBOTC, we used the ROBOTC motors and sensor setup. Inside of VEX Coding Studio, we'll use the robot configuration window, and we'll be able to visually drag and drop those things over. So without further ado, I actually do want to show performing some of these steps inside of VEX Coding Studio. And so I will launch it from my desktop. Okay, and what we'll see whenever we start up VEX Coding Studio is that we can start a new project. We can open up example projects, or we can open up recent projects. And regardless of whether you want to start a new project, open up an example project, or a recent project, you can choose to do so in ModKit, VEX C++, or C++ Pro. So one of the first decisions that you'll have to make is which programming language you will be choosing. So for our first 3 webinar series, we will be looking at VEX C++, and for the 4th week, we will take a look at ModKit. Okay, example projects is broken down by application. So you have motion, sensors, controller, screen, and competition. So there's lots of good example code inside of there. And then recent projects would be anything that you had worked on previously. But I will choose new project. I'll click on VEX C++, and I will choose to start a new VEX C++ project. Now, what we'll see here is the robot configuration screen that I was referring to. This is the visual screen that lets you drag and drop the different devices connected to your robot. So, for instance, if I had 2 motors connected on my robot, I could drag and drop 2 of these motors in from the left panel. Whenever I click on a motor, I can choose to give it a custom name, such as left motor. If I click on the pound or the hashtag symbol, I can choose which port it's connected to. And then if I click the small gear icon, I can choose the different gear ratio. Okay, so green or 18:1 is the default. I can also choose to reverse the polarity of my motor. So if you've built with VEX before, you know that the motors tend to be mounted as mirrored images of one another. So whenever you want to program the robot to move forward or backward, so that you can tell both motors spin forward, spin backward, this checkbox or this configuration box here allows you to just automatically reverse the polarity of your motors. I can do that again for my right motor. Choose the port that it's connected to, and verify that it's the gearing that I want. All right. For the sensors, very similar. I can drag and drop those inside of my program. I can click on them to give them a custom name. And I can click on the asterisk within the triangle to choose which 3-wire port it's connected to. Okay, so configuring devices is now very visual, very intuitive, I think. So students can look at their robot, see what's connected, and then drag and drop those devices inside of this space. Now, what I'll do to update firmware also, I will connect my Cortex to my robot. Or sorry, my V5 robot to my computer and power it on. Okay, VEX Coding Studio detects whenever my V5 brain is connected. And then if I need to update my firmware, what I can do is I can click on the little brain icon. And then if it needed an update, it would say so right there. Okay, so in the upper left corner, is where I click on the brain icon and I can update the firmware. VEX Coding Studio will go out to the internet, automatically see if there's any firmware updates available for the robot, and then download and deploy them as needed. Okay, so now I did want to show a little bit of programming. The materials that I show for the programming section are largely derived from support materials on the VEX website. So There is a STEM Labs section of the VEX website that has lots of great activities for what to do with your V5 robots. Also, one of those sections is named Transitioning from Robots to C. And the format of those materials is it shows a program written in ROBOTC that maybe you're familiar with, and then how to create that equivalent behavior inside of VEX C++ or ModKit blocks. So here we have a simple forward for time program. Inside of ROBOTC, every program started with task main. Whenever we wanted to spin the motors inside of ROBOTC, we used the motor commands, specified which motor, and then gave it a speed. We could keep those motors running for an amount of milliseconds using the wait1msec command, and we could stop those motors by again using the motor command, but by setting the values equal to 0. Inside of VEX Coding Studio, inside of C++, what we have is int main, okay, which is standard C++. Instead of the motor command, we have the spin command. So what you'll see is left motor dot spin and right motor dot spin. Now, these commands are actually really nice, really powerful because of the encoders that come built into the motors. Instead of just being able to say, hey, run at this motor speed, we can say direction type forward. We can give it a speed or an amount, such as 50, like we do here, and we can have velocity units in percent. We can also have velocity units in RPM. So rather than just saying, hey, turn on the motors and hope for the best, hope you go the right speed, the encoders will actually make sure that they start spinning at the correct rate. All right, and inside of VEX Coding Studio, instead of wait1msec command, we have task sleep, where again, what it's doing is it's holding the program flow at this spot in the program for the amount of time specified, 3,000 or 3 seconds. And then instead of using the motor command to stop the motors, we instead have a stop command. So we can say left motor dot stop, right motor dot stop, and then as a parameter inside of there, we can further specify if we want to, whether we want the robot to brake or to coast whenever it stops. All right, so what I want to do now is actually show downloading some code like this to VEX Coding Studio, or from VEX Coding Studio to my robot. And so I've pre-written some code, so I can go to my project and choose to open, and open forward for time. We can see that I have some motors configured. And if I click on VEX C++, we can see the code that makes up this simple program. Right? So inside of VEX Coding Studio, to download my program, I just click on this downward arrow right there. But what I want to draw your attention to first is I mentioned that you could download up to 8 programs to your robot. Well, how you choose that is with this little part of the interface that has a 1 on it. But when you click on it, you can choose 1, 2, 3, 4, 5, 6, 7, or 8. So the way that it works is you have this thing called like a program slot, so that you can choose which slot you want your program to take up. Okay, so if you are always choosing 1, you're always overriding the previous program. But if you want to maintain multiple programs, then you choose from these different download slots inside of there. Okay, but I'll go ahead, I'll click download. We'll get a little message that says download complete. And then to run my program, I have two options. I can play and stop my program directly from VEX Coding Studio. So it will send those signals over the USB cable to run my robot if it's connected right there. Or I can use the on-brain interface in order to show it. Okay, and so what I want to do is I want to switch over to showing the camera so we can actually see this running on our robot. Okay, so hopefully video's all coming through for you right there. I have my robot. It has the V5 brain right inside of there. It has my program loaded, which was named Forward for Time. I can tap on that, and I can tap one more time to run my program, and it spins the motors for 3 seconds as expected. The interface for the V5 is kind of similar to an iPhone, if you're familiar with that, or at least an iPhone when the iPhone still had physical buttons. So if you want to go back on your V5 brain, you can press the physical button, and that will take you back. If I want to run my program again, I can go back and I can run it again. Or I can continue to press the back button to get back to the main menu. All right. So what I want to do is throw a few additional resources your way to help you get started. I see that some of you are mentioning that you received your kits. That's great. So these resources will help you get started in between our webinars. One really great resource is that VEX does have an API for both ModKit, VEX C++, and C++ Pro. If you go to help.vexcodingstudio.com, you can see all of the different commands, the different keywords and parameters and how they work right there. So that's an excellent resource for knowing how to take advantage of the full power of your V5 and VEX Coding Studio. Another really great resource are the STEM Labs. These STEM Labs are really great curricular materials, different activities that are focused on different subject areas, math, engineering, programming, and at different lengths of engagement. So if you want to see how you can use your V5 system to learn some math or learn some programming, you can check out the V5 STEM Lab portal for some excellent materials there. The programming focused ones have some really nice programming tutorials that you can follow to brush up on the programming. Right. So thanks everyone for the time that we spent here today. If you or your coach or your teacher is looking for professional development with the V5 system in VEX Coding Studio, we will be offering that at the Carnegie Mellon Robotics Academy, both online and on-site. So check us out. And then for the last bit of class, I definitely wanted to be able to check out some of the questions that you had. So bear with me here for just a second while I try to parse through the comment box. Okay, wow, lots of great comments. Okay, first question that maybe everybody saw, but in case you didn't, there were some questions of whether or not VEX Coding Studio supported the VEX IQ. So this current build does not, but they do have the plans to do so in the future. So keep an eye out for that. I'm sure VEX will be announcing good news in the future for those of you looking for that. Okay, there's a question about the videos being saved for later viewing. So yep, one great thing about YouTube is that it automatically records these videos and then hosts them at the same exact page that you're at. So if you come back to this URL, you'll be able to check out the recording. Okay. Question from Timur. Coast meaning break type coast? Sure. So with the stop command, you are able to specify how you want your motors to stop. So break means like the robot, the motors will apply power to brake the motors to have them stop on a dime. That's B-R-A-K-E, not B-R-E-A-K. For coast, that means that it will allow inertia in the system to allow the robot to drift to a stop or coast to a stop. Okay, another question. So V5, you don't have motor controllers. So whenever you are working with the smart motors, nope. They connect over a new style of cable, the smart cables. That's similar to a phone jack. If you are using the 393 motors with the V5, then you would use a motor controller with those 3-wire ports. Okay. From Lachlan, what fundamental differences are there between VEX C++ and C++ Pro? Aside from the visual, sorry, it moved on me. Aside from some of the visuals. So one thing that you'll notice is that the robot config screen is used in VEX C++, but not in C++ Pro. C++ Pro, you do configure your devices differently. For the best answer at how things are different, though, it's best to take a look at that VEX API as it lists out all the different commands, how they're used, things like that. That will really inform some of the differences for you. Okay, another question from C Squared Marshall. Will there be a graphical ROBOTC version on VCS, not ModKit? So no, there are no plans to release ROBOTC Graphical for the V5 or within VEX Coding Studio. From Knox City Coding Studio just for the V5? Yes, currently VEX Coding Studio supports the V5 robot brain, but do keep an eye out for VEX IQ support inside of the future. Okay, from Gaming Warehouse, is there any way that you can test your program without a V5 brain? VEX Coding Studio will compile your code without a robot brain. So you can write code inside of there. You can make sure that it compiles. But to see how it runs on a physical robot, you do need a physical robot. There's not an emulator right now. Okay, from Nicole, will we be able to learn how to configure using C++ Pro in future webinars? Yeah, so if there's enough demand, let us know the subject areas that you're curious about, and we'll be sure to try to support you by creating webinars focused on that. Okay, from 41091A, how do you connect the V5 robot brain to your computer without using wires? Can you show how it is done? Thanks. I will try to show how it's done in a future webinar. I don't have everything here. I need to set it up, but the new V5 robot brain does support Bluetooth. Okay, from C Squared Marshall, will ROBOTC ever support V5? No, I don't believe so. I believe that VEX C++ and C++ Pro and ModKit blocks are the preferred languages for the V5. From Sandra, when selecting a new project in VCS, if you are working with VRC, do you select ModKit, VEX C++, or C++ Pro? Does it matter? I'm pretty sure you can use any of the languages. With the languages inside of there, be sure to check out the competition code, and you'll get example code for how to be compliant with field control hardware and those kinds of good things. Okay. From Gaming Warehouse, can you test your V5 code on a virtual robot? Not yet, but VEX has announced that VEX Coding Studio will support robot virtual worlds in the future. So that's another feature to keep your eye out for. That is coming in the future. Okay, from Gonzalo, what type of cable do you connect the V5 smart motors? So VEX inside of the new kits includes the smart cables. They are similar but not identical to a phone type cable. So if you're familiar with VEX IQ, it's a similar cable again, but it's not exactly that size. But the smart cables are similar to that phone jack style cable, and they are included inside of the kits. All right. Well, it looks like questions have slowed down. As you have additional questions, please feel free to hit us up with those, either on the CMU, CMRA Twitter, or on the VEX Twitter, or feel free to also post your questions here on this page. We'll be monitoring it. Good luck, everyone, getting started. If you have questions, things that you want to make sure that we cover, please feel free to send those our way. And then have a great rest of your day, and yeah, good luck.